Coming up in today's episode, can we rescue this 386 from the scrapyard? Stay tuned, find out soon. G'day mateys, welcome to a new episode. Today, I've already got it on the bench because it's a bit hard for me to make it appear like magic. I have come across an old 386 desktop computer. It's got a 5¼ drive, 3.5-inch drive. It's got a hard drive inside it. However, there's a bit of an issue. So I'm going to take this lid off on camera and I'm going to show you what the problem is. Now, I haven't plugged this unit in at all, so we're actually going to do that live on camera, just in case anything goes bang. Always makes for a good adventure. So let's take this lid off. Now, pull this out the way. And what have we got? Okay. Old style power supply. We've got 5¼ 3.5-inch. We've got a graphics card over here, which I don't even know what type that is. What does it say? I think it says WD, Western Digital. It does, okay. And we've got a main board. However, we do have a bit of an issue. If I pull this down, can you see down here in this socket there's a little bit of corrosion. If I flip this up, look at the Varta. What has it done? It has spewed all of its guts all over the main board and we have a heap of corrosion. So I'm going to attempt to fix this. But first, let's see if it actually works. If it doesn't work, it might be pointless. It appears it's a 386 processor down here. I think it's an SX16. So it's a bit of a slow one. It's got 30-pin SIMs. This is the era when I started playing with IBMs. My first IBM was a 286. It was a WYSE, W-Y-S-E. It was an 8 MHz machine. We ended up putting a RAM expansion card in it. And I remember actually having a full height MFM 60 megabyte external hard drive. And the drive used to get so hot that we actually drilled a great big hole in the desk and mounted a fan under the desk so it would blow cold air over the hard drive. And we had the hard drive cables going out through one of the slots on the back of the computer here. Because it originally only had a 20 meg. And we thought initially 20 meg, you'd never feel that. And of course, what's the size drives that I run in my machine today? I've got about 20 gigabyte of data in my current machine that I use in the studio. So it's quite amazing how things have changed. So let's grab a power lead, move this back into frame, and we'll see if anything goes pop. This could be kind of bad. So I do have a VGA lead here to a television actually that has VGA, which is interesting. I don't have a VGA capture card. It's the only thing I don't have. We've got an old Honeywell keyboard. These were a very sought after keyboard back in the day. When we were selling computers, I used to actually own and operate a computer repair service centre. This is a good old Honeywell keyboard over here in Australia, very popular. This is what they used to call a 104 or 105 because it had the Windows keys. The ones prior to the Windows keys used to be a 101 keyboard. It has a 5 DIN pin plug, which you don't get those anymore. We've got PS2 or USB. So this is well before USB. So we'll plug the keyboard in, like so. Now the only thing I haven't got on the bench is an IEC power lead. So let me just grab one of those. I've got one here on the floor. Actually, this is what you call the world's longest IEC power lead. It's about a 5 meter one, but anyhow, it will do. So let's plug it into the mains firstly. We are on circuit breakers here, and we do have earth leakage detection in the workshop, just in case. So I'm going to plug that in. I'm going to plug the power into the machine. Okay, the power switch is definitely off. So there's now power feeding into the machine. But with these old machines, it's not like an ATX where the ATX has a standby power mode. and when you push the power button, it does a power good test and fires up. These actually switch 240 volts on the power switch. So when you work inside these things, you do have to be cautious. It's the reason why I generally don't wear a watch. Back in the 90s, I was wearing a watch one day when I stuck my hand inside a computer and wasn't really being careful enough and got electrocuted. That was a fun time. After that, I stopped wearing watches. So, let's pop on our TV over here to the side that you guys can't see. It's just for my reference only. So this episode will be about restoring the motherboard if we can. And we'll take it from there. So waiting for this to boot. Waiting for TV to boot. Isn't that a strange situation? Okay, let's go to the input, which is called PC. Okay, so apparently that is on PC. So let's turn this on and see if we get a bang or a pop, or if it actually turns on. 3, 2, 1. Holy dooly. It actually works. I can't believe it. It's coming up CMOS battery state low, CMOS display type mismatch, run setup utility. It's coming up in a red screen, which I've never ever seen before. They're normally black. It could be just my cable's a bit dodgy. We'll check that later. Let's press delete and see what happens. Holy dooly. It is actually working. Now, it's got a hard disk utility in here. Does it actually detect the hard drive? No. So we'll have to check that out. Standard CMOS settings. What have we got? Okay, let's tell it it's got an A drive. A drive is a 1.4. A B drive is a 1.2. EJ/VJ palette, correct. Telling us that we've got 2 meg of RAM. I think that might be wrong. Okay, let's write to CMOS and see what happens. I'm really surprised that this works. You can hear the RAM counting. It's got 2 meg of RAM. It says 1920, which is a bit of a strange thing. Press any key to continue to actually boot. So it's doing a boot search. I don't know what this hard drive is, so I'm going to have to pull it out and check out byte sectors on this. On these old ones, it doesn't auto-detect, but it actually boots, so I'm really surprised. In that case, I think we will pull it apart and see if we can restore that damage to the main board. I'll get you some nice close shots. So let's get this all apart, and we'll take it from there. Woohoo! So we just powder off. Just going to pop the video card out firstly. Okay, the video card. Bit of corrosion just on the bottom, but nothing too bad actually. That could clean up quite well. That might be why we're getting a bit of red. I can see there's a little, you can probably see more of this corrosion now. I can see a little bit of corrosion on that socket there. Just going to reseat this and see if actually, if I don't get that red screen. Let's have another quick go. Yeah, there we go. So we've now got the proper black screen. So it's just a video card not in properly. Great. Fantastic. Okay, let's carry on. We'll unplug the power, unplug the keyboard, and let's get this motherboard out. So there is our video card. As I said, it's 2 BIOSes on this, so you got the high and low. That's because we never used to have enough chip space in these chips, although very expensive. It looks like we've got half a meg of RAM maybe. I'll read those chip numbers shortly and we'll figure out what that is. And it's a Western Digital WD9000 graphics processor. Great, pop that across to the side. So I don't lose this screw, let's just pop it back into the case. Also, back in the day, so working on this, you look down here, we've got keyboard LED and keyboard lock. These have a little keyboard lock on them sometimes. Yep, it's over on the front. Then we've got the blue and white. It's probably going to be PC speaker, but none of this is labelled. None of it at all is labelled. So I'm going to have to take some photographs so I know where it goes when I put it back together. So in here we have the, if we can get the screw out. This is what they call a super I/O card or a multi I/O card. Pop that out and flip it around for you. And got a couple of UART chips for the serial ports. You got the floppy controller, hard drive controller, printer port, and a game port. And then you got the old manual jumpers to enable and disable what you need. So great. We'll unplug this. And here we go. Hard drive LED goes straight to the card. So I'm going to grab my other device and take a photograph of that.
A few moments later.
So I've just taken some photos with my mobile phone. So let's pull this out. And see that red goes to pin number 1. Because it is like printed here, 1 and 2. And on the IDE, 1 and 2 as well. So easy. This is the LED for the hard drive to flash on the front of the case. And we can just unplug these COM ports here. So that was detecting, so obviously it appears to work. It was detecting floppy drives and so forth, so that's great. Now, these things are never easy to work on. A bit of like spaghetti junction. So I'll get rid of the keyboard. Just figuring out how this one comes apart. That, there, earth wire. There's a strut here that goes across. Can't get to it because of the front panel. Does the front panel come off easily? No, it's all screwed. So see, these old computers, you have to take everything literally apart to get into them. So I think the easiest thing for me to do is to probably remove the power supply so I can actually have a look down here. So the power supply looks like a standard power supply that you're familiar with today. However, these ones have negative 12 volts and negative 5 volts. The current ATX standard does not. These are not ATX at all. It's called an AT standard. And I'll show you what the plug looks like. And this is Soltech, which I used to see a lot of these power supplies back in the day. So, something that they used to do. There's a brace on the bottom here with 2 extra screws. You don't get that on modern ones. Down here is power connectors. With these, you actually sort of push them over and then up. So you push it away and then up. And you see you've actually got 2 plugs here. Now, some people get confused on how to put them back because they're not keyed. So you can put them wrong. But the trick is black together. So always black together, then into the main board. You won't make any mistakes. The black is the ground. If you do it the other way, you are going to do severe damage because they're the 12 volt lines. And negative 12 and negative 5, you're going to damage the board. So always black together. So that's done. Now we need to get this motherboard out. Put this cable through here. To get this out, I'm going to disconnect the power off the hard drive. So there we go, just a Molex. Not easy to remove the power supplies in these because you've actually got to remove the power switch, and to remove the power switch I've got to pull the front panel off, which I'm trying to avoid to do, obviously. Right, let's move this IDE cable to the side, and we'll have a look at this main board. So I'm going to take a quick picture of some of the damage, and we can show you what that looks like currently, and we'll start to pull the main board out. To pull these main boards out, they'll have 2 screws. So there's one under this plate here, so where the COM ports are, which you can't actually get to the screw easily. So I need to get to a screw through here, which will pull out the riser plate here that has the 25 pin and 9 pin serial ports. Under there, under this plate here, straight through here, and you can see my screwdriver doesn't reach. I'll have to get my long ones. There's a single screw that holds the board in. There's another screw that's over this side, so there's only 2 screws that hold the main board in. The rest are these plastic riser clips. Now, sometimes you have to squeeze them and pull it out, and or sometimes they'll slide this way, sometimes they'll slide that way. Looking at the board design over here, I can see it looks like they're going to slide that way. So we'll give that a go. So let me just grab another screwdriver and we'll make this so.
A few minutes later.
So I do like a lot of the toolkits that are out there, but they don't give us screwdrivers like this anymore. So in we go. And what's happening here is that this goes into a copper or a brass nut, and it's actually turning. So I'm going to have to keep doing it and undo it fully, and then have to slide it out with the actual copper, or the brass standoff is what they call it, or a standoff, with the motherboard, and have to pull it off with a pair of pliers once we get it out. So let's try to slide the board away from me. There you go, you can see that's moving. Just got to do a little bit of jiggery pokery, and voila, the board is out. So remember how I said the standoff was turning? This is the standoff just here. So we'll get rid of that straight away. Back to a normal screwdriver. Hold it with our fingers, and we can then just take that out. Screws on the end of the screwdriver. And look, you have fibre washers back in the day. Amazing stuff. Interestingly, why that was moving around is that there was actually no... Oh yes, there it is. A little bracket. I have never seen one like that before. I'll show you what I mean shortly. Okay, so here's the main board. It's out. And this is where all the damage is, down here with this horrible, nasty Varta battery. We'll stop recording for a second and we'll show you what I mean.
A little longer than a few minutes later.
So we'll unplug all of these. I've taken pictures. That one there is power LED and key lock. Blue one here is PC speaker. Purple and black, labelled reset switch. We have a single orange wire here, and I have no idea what that one is. And then we have a 3-way switch here, which is turbo switch. So yeah, so now the motherboard is fully free. So let's grab the case off the bench, and we'll have a look at this motherboard.
Minutes later.
So here is our motherboard. Here is that nasty Varta battery. So they're an alkaline NiCad battery, and eventually they just spew out their guts. We have this issue with Amiga computers. Apple has issues with it. Just any old computer, you know, 20 or so years onwards, will most likely have one of these. It's here for the CMOS battery backup, so it keeps a real-time clock, so your time and date, keeps your CMOS settings, or your BIOS settings, everyone seems to call it these days. But they do fail eventually, so we'll actually remove this, and we'll put in a modern-day replacement, and because this is rechargeable, I won't be putting a rechargeable battery back in it, so I will actually have to do a little modification with a diode to stop it trying to charge the coin cell battery that I will fit into here. But I don't know if you can see, but if I get this, look at this. It's absolutely screwed. So let's put it down on the bench. We'll get some cutters and we're going to cut that off firstly, and I'll desolder it later. I want to make sure that we're not going to cause any more damage. You can also see we've got a little bit of green corrosion here, just starting in this connector. So we'll also fix that. I don't know if you've seen a previous episode, but to clean a lot of this off and stop it carrying on, we actually use white vinegar. So double strength white vinegar. Get it, you know, hardware stores or even supermarkets here in Australia. So let's get this battery off the board. So got our cutters. Just go in here, snip, go around the other side, and that battery is done. We'll be back really soon.
More moments later.
So The battery is off. Well done. Fortunately, where this has actually spewed its guts out, there's a really big ground plane, which is great because if it had gone into all these tiny little tracks over here, the board would be not worth repair. But because it's there, I think we're actually going to be okay. It may have got under this socket, but I don't think so. And the reason I don't think so is normally you'd see some green on the pins here would start creeping up. That socket is for a Masco processor, which this board doesn't have, so that's not an issue. So let's just firstly, we'll spray it with a bit of alcohol, isopropylene alcohol. Just do a bit of a spray, and we'll get the toothbrush on it firstly, just to clean up to see what we have, and then we'll go ahead and treat it and stop it moving on. There's my toothbrush. So, that has eaten a lot away, but mainly it's that ground plane. There's a little bit of stuff that's gone through the board here, where there's meant to be a possible socket. There's nothing through the back. You can see there's a little bit of here, a little bit of corrosion just here. Fortunately, I think most of this, look at that, that is just on the surface. So if I clean that off, hopefully, use a bit of solder mask if we have to. Get in here as well. Yep, that's not, I don't think we're going to be in such a bad... Normally, if this was a multi-layer board with lots of little tracks everywhere, like it normally is, this would not be savable. Great. Yeah, cleaning up on here quite well. Okay, get some cotton swabs. Okay, so we need to clean this up, so we actually need to use some white vinegar. Here's a tub I prepared earlier. I had some other bits working in here, but we can still reuse it. We'll just dip our cotton Q-tip or cotton swab. Use this to dab it on to neutralize the acid. I like to use to neutralize it and stop it reacting. Put a bit in here like so. Might get some cotton wool balls and just sit them on top of there. So I'll just get in here and just make sure that we're not missing anything. It's coming out pretty clean. We'll pop this bias chip out in a little while and just make sure that there's nothing underneath it. But it's actually looking quite good. I think it's been localized just to this area here. Okay, so we'll leave that be for a while, and we'll see you in a short while.
Soon after.
What I've just done here is I've used some cotton balls after dipping them into some of the vinegar. I'm just leaving those to sit on there for a little while, and we'll see if that deals with the corrosion issue. It has lost quite a bit of the ground plane, but that's okay. We can do without it as long as we can get it to keep working and so forth. We'll leave this on for quite a while, and then we'll put it under our microscope here and see how it looks.
24 hours later.
Another day, another dollar. So we left this going for quite a few hours. We've come back to it. We've taken away all the, what we did, we soaked these cotton wool balls in vinegar, left them sat here overnight. And then we came back to clean it. So basically what we've had to do is use some isopropyl again. Got a bit of a squirt where we had a bit of build-up. Came in with a toothbrush. Although it doesn't quite get into those gaps, but it gets into here quite well. We scrubbed all this area here. I'm just doing another bit of a clean. Can't have too many cleans. Being ISO, it'll clear away quite nicely. And what you can probably see is that all the copper around here, where the Varta battery was, has actually totally disintegrated, it's disappeared. That there is actual PCB board. Fortunately, on this designer board, all this whole area here is a ground plane. Now, I've gone ahead and tested continuity from ground points through the board and tested through all of this area, and it's all still connected and all still working, which is brilliant. So we are very, very lucky to resurrect this. Now, I was originally going to solder a new battery across here and put a diode in to keep it running for the real-time clock and just keep the settings in the CMOS. However, tracing through with the main board, the positive terminal here runs all the way down here, runs across through here, back through a through hole. Here's the trace again, here, runs down through here, runs down through here, and then I notice it goes to this jumper block here. So then I trace through and everything else, and it turns out this main board is just great. If this jumper is in position here, in position 2 and 3, there's 4 pins, okay, it then uses the Varta battery here, and it will actually charge it, and that's part of the charging circuit here. However, if you remove this jumper and then put your power across these terminals here, so I can use a lithium battery, a 3.6 volt up to 4.5 volts actually, across here, so across these 2 pins instead, remove this middle jumper, it then goes through this bias protection circuit here, so it doesn't charge it. So it means that I don't have to, try to solder a coin cell battery compartment down here and add a diode. I can just easily pop an external battery on the board, and it is all resolved and all rescued. So back down here to the damage, as this is slowly drying up, what we're going to do is, I can't just leave this exposed copper. See how it's all shiny? I can't leave that, because if I leave it, it's going to start corroding again, and we'll lose more and more of it. So what we're going to do, we're going to seal it. There's a couple of ways of sealing it. I do have the actual green, I can't think of the name of it right this very second. Solder mask. I actually do have the green solder mask I can put on here and then use a UV light to cure it. But green on a copper, this colour is going to look really ugly. It does look ugly, yes, it does look ugly the way it is currently. I won't disagree. However, I think it will just look really terrible. if I go adding green into the equation. So what I've decided to do is I've raided the house, and I have found Gel Envy Diamond Top Coat Color Stay. What this actually is, it is a clear nail polish. So what I will do is, once this is fully dried off, which it's almost there, because I can actually do it a bit quicker if I get the heat gun out. I'll cover all this area in the lovely nail polish. It's a clear one. It's a clear lacquer, so it's not going to look odd. And that will then protect this circuit from doing any more corrosion or having any more issues. So that is absolutely great. I might do a little bit of a clean up just down here. You can see I'm just scraping away some more of the stuff I've missed. So there we go. So I'm just here today. I'm just using one of these little picks. Got a few of these. They're quite handy for getting out little rubber feet and all sorts of stuff. Got a couple of angled ones, and this is obviously a straight one. I've got a hook one as well. But it's just good to get in here and scrape. The other tool I've been using quite successfully is this. So it's a stiff brush on one end, and on the other end it's a little wire brush, and I've been able to get in here with a little wire brush and it gets rid of any little loose dags that are hanging around, which is really quite handy. So just get in here, clean up some of this stuff. Actually, so we did have a bit of corrosion in there, so we cleaned that up with the vinegar also. We've got in and done a bit of a scrub. What I did do to make sure that there was no issues, I got the multimeter out. We put it onto continuity mode. I push the button so you can actually hear the buzzer. So if we touch these two together, we have continuity. So what I wanted to do is to make sure that these weren't damaged. So I was able to go into the very first pin here and then measure this one over here. And of course, you then get a nice beep. There you go. Go to the next one, the same. Go across to the opposite side of the connector. Good. Again. Yep. So I worked my way down through all these pins just to make sure that there wasn't any issues. So we've gone through and checked those out. So that's great. So we'll just wait for this to dry, and I'll be back shortly, and I'll show you me applying some of the nail polish.
Much later.
So we've just been over to the microscope, and we had a good look under there, and we had to do a little bit more scraping. You would have seen that just before. So now we're going to treat this area so it won't corrode anymore by protecting it from the elements. So we'll just go in here quite easily and just brush on some clear nail polish. Now, oddly, I actually don't mind the smell of nail polish, but I hate the smell of acetone. Go figure. The nail polish always reminds me of those cigarette lollies you used to get. You used to call them fags over here in Australia, and they sort of smell like that. I don't know why, but they always have to me. So there we go. We're just covering this up. Not that I condone smoking. I'm a non-smoker. But I just thought it was something trivial. Okay, there we go. So, just go around, make sure that I have covered everything that had a bit of corrosion on it. Being clear, see, it doesn't look terrible. If I put green solder mask all over this, it would have looked hideous. So, there we go, just make sure I'm getting into all these spots. That's great, so we're going to leave that to dry for a while. Now, normally this sort of stuff takes like 5 or 6 minutes to dry, but because it's on a circuit board and so forth, I like to leave it for an hour. So I'm going to leave this go for an hour, and then we'll come back to it a little bit later.
1 hour later.
So we've now polished over all of this area here to protect it, so it shouldn't corrode any further. It's all been cleaned with the white vinegar, as we said. You can see how green this is from all of the corrosion, the acid build-up. So, on this board, I'm not going to fit the battery here. What I've decided to do is to get a CR2032 holder that I've got here. I've soldered some wires on, we've heat shrunk it up. Got some DuPont cables on the end, and that's going to go down here onto this battery connector. At the moment, in this position here with the jumper on, that enables the battery down here. However, if we take the jumper off, like so, there's 4 pins, and it's then for an external battery. Using the multimeter in continuity mode, I needed to figure out which one of these pins was the ground. So on a motherboard, remember earlier on in the piece I said about the 4 wires going together, the 4 grounds going together on the power supply connector over here. So we know that this is ground here. We can test, just make sure that it's working. Yep, we can test that by going to the keyboard connector. Great. Nice and easy. And then go through here. No, no, no. There we go. That's ground. And I knew that these two here was the part of the charging circuit going across to there. That's why I was linking. So that leaves this one here. If I follow that across, I can see it goes through this diode here, then comes across, and then goes through again into this circuit here. So that's to stop it from being charged. So we then know that that is then negative, that is then positive. So on our battery connector here, we have a positive side and obviously the negative side. Positive side has 2 legs. We've trimmed one leg off because we don't need it. We've attached a white wire to the positive side and a black one to the ground, or the negative. So let's put these onto the pin header. Like so. So that's ready to go, and we'll use a bit of double-sided tape inside the computer case. We've got the CR2032 lithium 3-volt battery here. This may be a little low, so I'm trying this. If this doesn't work, I'll have to go for a different method, but normally it will be enough. Always get a good quality one, a Panasonic or an Energizer or a brand name one. Don't just get a generic one for a couple of bucks, because they just never last. Also, when handling these, don't handle them like this, because you'll end up putting a little bit of your body's natural greases across the terminals, and it acts as a resistor and runs it down quicker. So just be very careful handling them. So we'll grab this out of here, we'll pop it in here, and then we'll pop this, I think we'll pop it back into the case, and we'll fire it up and see if there's anything on that hard drive. So here we are with the 386 back in studio number 2. Got it all plugged in here, got it set up on the TV. Going to fire it up, head into the BIOS, and set up the hard drive and the floppy drives, and let's see if it boots. Wish me luck. Here we go. Okay, into the BIOS, good sign. I'm doing this upside down, so I might turn the keyboard around and make it a little bit easier for me. So, 1997, a long time ago. So, we'll leave the date for now, that's fine. Hard drive, I believe it's a Type 17, which would make it a 41 megabyte hard drive. It's a Connor hard drive. The A drive is a 1.4, the B drive, 5.25, is a 1.2. Okay, that's pretty good. Let's have a look at standard CMOS settings. Let's go down here. Floppy C cup, turn that on, I always like to hear that sound, nothing better. And result to boot A then C, that's good. We're shadowing, yep, and also system ROM shadow, awesome. Take that away. It's under advanced, it's about wait states, and we are relocating 256K of the memory, so that's good. Okay, let's write to CMOS and exit. Will this boot? I'm very curious. Look, there's that noise. Look at that! We have boot! What is going on here? Vet antivirus. I haven't seen that in a very long time. This version of Vet is now obsolete. Yeah, in 2022, very obsolete. It should give us an option here to quit. There we go. And here is my first look at this machine. So, DOS commands, Duke Nukem 1, Microsoft Works, Print Shop, Windows 3.1, X3 Gold. I haven't seen that for a while. Okay, let's have a look at X3 Gold. Enter password for X3 Gold. That's the problem with some of these old computers. They have passwords. 1, 2, 3, 4. No. 0, 0, 0, 0. No. Password. Let's try it. No. Okay, well, let's just get out to DOS and we'll have a bit of a squiz in there. And we need a password to get to DOS. How about if can we exit out of here? Oh, F1 maintenance. And we need a password for that too. Okay. What does work? Well, we have a lot of games in here. Astrofire, Mass Rescue, Captain Comic, Darts. Gobman. I have no idea what Gobman is. Commander Keen. Oh. Let's see if I need a password for a game. Oh, got all the Keens on here. 1, 2, 3, 4, 5, and Keen Dreams. Let's try number 1. Will it work? VGA card detected. Compressing graphics. Well, we don't need password for games. That's interesting. Good old Apogee, hey? Well, that looks like it works. Let's... How do we quit? Yes. Well, I think we're probably just about done for today's episode. The machine does work. I think in a part 2, we actually might see if we can get out of here. Maybe if we do a Control-C on boot up and get into DOS, we might be able to go in, use a hex editor, see if we can figure out what the password is. But it's a working machine. So just shows you a little bit of white vinegar, tenacity, lots of grinding. Anything is possible. So thank you very much for tuning in today, guys. And we'll do a part 2 on this 386, saving it from the scrap really soon. Thanks for watching.